We have learned how to define response spectrum by different codes in the UBC 97. Here I have defined the response spectrum in the zone 3. Okay, now I will go in the load patterns. Here I have defined the equivalent lateral force load patterns that is used for equivalent static method. Here I have changed the parameters as same as I have defined in the response spectrum. Okay, in the zone 3 and soil profile SD. Here are the parameters also CA and CV. Here is the over strength factor R 5.5, that is intermediate moment resisting frame. That all parameters I have discussed in the equivalent static method. Okay, so now I will define the new load case which will define the response spectrum. Here load cases, here is already defined. I will delete. Okay, all the load cases that are defined in the load pattern are present here. Now I will define a new load case and name the response spectrum in x direction. Okay, load case type, that will be response spectrum. Okay, the mass source that we have defined in the defined mass source, that is selected automatically. Now I will define add the load. Okay, but basically I have clicked 2 times. Acceleration in the u1 u2, there are basically 3 directions: u1, u2 and u3. U1 is the x direction, u2 is the y direction, u3 is the z direction. First I have selected the x direction. Okay, here I will select UBC 97. I am showing the how to apply the response spectrum using UBC 97. You can apply according to your country as per your as per define the response spectrum according to your country. Okay, here is the scale factor about multiplying factor. Here as we have also did the multiplication factor in the equivalent static method. Here the multiplying factor, you have to multiply with I, is the importance factor of the building. For example, if it is a hospital building or nuclear plant, etc., then you have to definitely assign the response importance factor. G is the gravitational acceleration constant, R is the response modification factor. Okay, so our response modification factor is 5.5 and G is a 9.81 in meter per second square. If it is a 9801 millimeter per second square, units can be changed. You have to just first of all verify what unit system are using in the scale factor. Here in the information you can see the second option of acceleration in translational direction. It is in millimeter per second scale, so that's why it is 9806 millimeter per second square. G is already multiplied. Now I have to multiply by 1, that is importance factor, divided by 5.5, that is a response modification factor. Okay, here is a parameter. So now the second I will select the u2 direction. In the x, you have to also consider the 30% effect of u1 direction. For that I will just copy C, Control V, multiply by 2 by 3. Okay, why I did that? Here in the code in the UBC 97, the requirement that orthogonal effect be considered may be satisfied by designing such elements for 100% of the prescribed design seismic forces in one direction plus 30% of the prescribed design forces in the perpendicular direction. Means we can consider the 100% loading in the one direction and 30% loading in the other direction. Then we can combine the results of these both directions by SRSS method, means square root of sum of squares. Okay, there is also some. Okay, so that's why I did 2 by 3. Sorry, I have to do 30%. Control C, Control V, multiply by 0.3. Sorry, I did the wrong calculation. Now again I will also select the same UBC 97 spectrum, response spectrum. Now I will also define in the response spectrum the vertical component, that is third. Every earthquake, the real earthquake, have three components: X, Y and Z. So this response spectrum is a here the very good brief of the response spectrum. In order to perform the seismic analysis and design of structure to be built at a particular location, the actual time history record is required. That is the best requirement. If you are designing a building in a location that where the earthquake record is available, that is best. But however, it is not possible to have such records at each and every location. We can't have time history records for each location. Further, the seismic analysis of structures cannot be carried out simply based on peak values of the ground acceleration, as the response of the structure depend upon the we cannot use on the peak values. For example, let's say the peak acceleration use 0.3 or 0.2. So for the good response of the structures depend upon frequency, content of the ground motion and its dynamic properties. To overcome this difficulty, to do not use just peak factors. For that, to overcome these difficulties, the earthquake response spectrum is the best solution. There are computational advantages in using response spectrum method of seismic analysis for prediction of displacements and member forces in structural elements. The method involves the calculation of only of the maximum values of the displacements and member forces in each mode of vibration, using smooth design spectra that are average of several earthquake ground motions. So the response spectrum that we have defined in the response spectrum, that is a smooth response spectrum. Okay, so that's why in the book that is mentioned that is a smooth response spectrum. So now I will again consider the in the U3 direction. Okay, here I will select UBC 97 and I will consider the in the vertical direction I will consider the effect 2/3 of U1. Okay, so that's how you can define the loading in the response spectrum in the X direction. Here for combining the results, I will use the model case, that is we have defined the same name. For the combination of the models, for example mode 1, mode 2, mode 3, here is a complete quadratic combinations. There are different methods, but here I have selected the same as default, complete quadratic combination method. For the directional combination type SRSS, as per recommendation of court, you can combine by SRSS method. So I will left as it is. So modal damping, that is 5%. Diaphragm eccentricity, that could also specify you have to consider 0.05, means 5% accidental eccentricity. You can adjust for each story. Here I have selected for all the stories. Okay, for all diaphragms. Okay, so that's how we can define the response spectrum in X. Likewise, I will also define in the Y direction. Okay, here all the parameters are same, but here I will do U2, here will be U1. That will be the Y direction. Here is a complete parameter. In the U1 direction, that is 30%. In the U3 direction, that is 2/3 of U2. Okay, so rest of the parameters will be same. Okay, so that's how you can define the response spectrum in X and Y direction. Okay, now I will define in the load combinations. Okay, here I have to edit the load combinations. For example, here I am saying that is a dead, super dead, modify, dead, live, super dead, wind. Wherever earthquake combination comes, I will change. Okay, here earthquake X. So here I will select the response spectrum in X. Now we are designing the building according to response spectrum analysis method. So that's why wherever here again in the X direction, I will select response spectrum in X, modify. Basically two combinations are coming same, so you can also delete. The previous one is also same. So here in the Y, you will select the response spectrum Y. So basically two basic combinations of earthquake that are used: 1.3 dead, one live, and one earthquake. That is again the same. Okay, so now that is 0.8 dead and one earthquake. I will again change it to, sorry, modify. Okay. Okay, so now I have also defined the load combinations in which response spectrum parameters have been defined. After defining the load combinations, now one thing more, you have to, in the mass source, modify, you have to check this option, include the vertical mass, because we have now considered in the response spectrum analysis the three components X, Y, Z. For lateral components X, Y, for vertical components we have to check this option, then mass source consider the vertical option. Okay. Okay, now I will run analysis and design, and before running the design I will apply the multiplication factor. So for the calculation of multiplication factor, either is it required or not, so I will run analysis. Why this multiplication factor is needed? Because for example, if we are designing a building in a specific location, then the response of that building should be within the limits, means the reactions, the base shears. The code says that your response spectrum results should be within the 85% of the equivalent static method. So we will check and then multiply the multiplication factor. Okay, now the analysis is complete. Now I will go in the tables, analysis, results, reactions, base reactions. Let me move up. Okay, now I will select the load combination in the earthquake, and second response spectrum X max. Okay, sorry, I have to click both. Okay, here. So here the reactions due to equivalent static, that is 5869, and our base reaction due to our response spectrum in x direction, that is less. So that's why we have to multiply the factors so that our reaction, base shear reaction, should come near to the 5869. So for that we have to apply the factor 5869 divided by 3729. Okay, the factor is 1.573. In x direction, that is 1.573. So the multiplication factor in the y direction, here I will select earthquake in the y, and then the response spectrum y max. So here in the y direction, that is 5869, also the same reaction, but in the response spectrum there is some variation. Here I will put 666. Okay, in the y direction the multiplication factor is 1.6. Okay, 1.6. Okay, so now I will apply these factors and again check, come back and check that is it the results are matching or not. Okay, go to again define response spectrum, in the load cases. Here are the both response spectrums in the x and y. Modify. Here I have selected the x. For the x the factor is 1.573. Okay, I will multiply 1.573. Let me copy the multiplication factor, Control C, and press enter. Again enter, enter. Why I have applied to the all the parameters? Because the combined effect is in the response x, so that's why I have applied the multiplication factor in each direction. Okay, now in the y direction, that is 1.6 multiply by 1.6, copy, enter. In the y direction, in the u1 direction, enter. Okay, okay. Now I will again run analysis and check that multiplication factor is coming nearable. Analysis results in the reaction. Now the analysis is complete. Base reactions. Here see in the y direction, now the results are matchable. So it means the response spectrum we have defined is as per our requirement. Okay, so we can use in the design. Similarly, let's see in the x direction. specs x max in the y direction, in the x direction. Okay, now so basically the difference in between these values can be up to 15%. That will be okay. So now the results are much looking prettier than the previous one. Now the analysis is complete and you will apply all the checks, irregularity check, drift ratio check, mass ratio check. So all the checks that I have discussed one by one in the previous lectures. So now I will go again further in the design. For the designing, you can check the preferences. Okay, in the design, concrete frame design, select design combinations, all the design combinations in which, let's see here, response spectrum X. All the response spectrums have been defined in the load combinations. I will go concrete frame design, start design / check. Okay, now the design is complete. I will go into design, concrete frame design, display design info. I can see the longitudinal reinforcement that is already appeared. Now rebar percentage, apply. Okay, rebar percentage, and now I will check verify all members passed or failed. Okay, all members are passed the design check, so it means our members are designed according to the response spectrum analysis. So we can also decrease the sizes of some beams and columns and again check, analyze and design so that we can economize our sections. So these are the designs of beams, columns. For the design of shear walls, again before applying the design, before designing of shear wall, you have to again go in the define load combinations. In the walls combination, you have to again similarly apply the response spectrum Y or for all the combinations for the walls. Then you will again run the design for the shear wall. So that's all for the response spectrum analysis. Have a nice day.